Hello guys, this is Anupam. On behalf of the Impulse Group, I would like to discuss a problem related to drive. The question states the torque speed characteristic of motor Tm and load TL for two cases are shown in figure A and figure B. The load torque is equal to motor torque at point PQ, here P and Q for system A, and RS for system B, R and S. The stable operating points are option A P and R, option B P and S, option C Q and R, option D Q and S, and the solution of the problem is discussed here. For system A, the torque speed character is like this. You can note the motor torque is positive but the motor speed is negative. That means the motor is operating in a braking mode where the motor truck itself tries to slow down the motor and keep it into a halt, that is zero speed region. But the load is somewhat opposing the motor truck and tries to run the motor at some point at some speed which is maybe point P or maybe point Q. Now let's consider the point Q in this region where speed is more than the point speed at point Q, the TL, the load torque, is somewhat more than the motor torque. This is the load torque TL and this is the motor torque. And now you can see the load. Since the load tries to drive the motor, the speed will increase and the speed will follow this. The speed will increase and follow in this region. Now when the speed is less than at the speed at point Q, again the load torque is less, the motor torque is more. That means the motor will try to slow down the rotor and the speed will decrease. So the point Q cannot be a stable operating point. Similarly, you can consider for point P. For point P, consider a speed where the speed is less than the speed at point P, this speed. Now you can see the load torque is more and the motor torque is less. That means the load will try to drive the rotor and so the speed will increase. That means the rotor will accelerate and it will try to approach the point P. Similarly, you can consider at a speed which is more than the speed at point P, and you can find the motor torque is more than load torque, so the motor will try to decelerate the rotor and again the operating point will approach point P. That means for any small disturbances around point P, the final equilibrium will be achieved at P. That means the P is a stable operating point. Similarly, for system B, the torque speed characteristic is given like this, and the operating points can be R, this point, and can be S, this point. Now consider a point on R where the speed is less than the speed at point R. The motor torque is, you can see the motor torque is less. The motor torque is this much, and the load torque is this much. So the rotor will decelerate and the speed will come down and the rotor will come to halt position. That means the speed will become 0. For the motor torque is more, the load torque is less. That means the rotor will accelerate and the speed will increase. That means the R, it implies that R can't be stable point. Now consider point S. For point S, if you consider this point, at this point motor torque is more and load torque is less. So So the rotor will accelerate and the operating point will try to approach point S. Similarly, beyond point S, motor torque is less, load torque is more. So the operating point, the wheel tries to approach point S. That means for small disturbances around point S, system will be stable. So S is stable operating point. Many of the students can make the mistake, skip the information that here speed is given in y axis and torque is given in x axis. Be careful while solving the problem and you will definitely get the right result. Thank you for watching the video. Have a nice day.